So these are our steps for proving something by induction, and we're starting with series of numbers. So they'll give us a series and they'll say that it's equal to a sum, okay, some SN formula, okay, and we just have to prove it using our steps. So example 1. So this is the question. Prove that for all values of n, 1 plus 2 plus 3 plus up to n is given by n over 2 bracket n plus 1. Okay? So they're saying if you were to add all these numbers up to n, you would be able to use this formula and get the same answer. Okay? So our proof, we know it's 3 steps. First one, okay? Prove true for n equals 1. Now in this scenario it said prove true for all values of n. It didn't say for all values of n greater than or equal to 2. If it said for all values of n greater than or equal to 2, you'd be proving true for n is equal to 2 first of all, because they're telling me it's not true for n is equal to 1. But in this scenario they didn't say that. They said prove true for all values of n. Okay? So you take the first value of n equals 1 and you prove it true. Basically they're saying if you add these numbers up as far as 1, which basically means 1 equals. Okay? Now on this side you have 1 over 2, 1 plus 1. Okay? So you get 1 is equal to a half by 2. 1 is equal to 1. So that's true for n equals 1. If it was prove true for all values of n greater than or equal to 2, you'd have 1 plus 2 on this side. Okay? If it was prove true for all values of n greater than or equal to 3, you'd have 1 plus 2 plus 3 on this side. Okay? And then you'd have 3 over 2 bracket 3 plus 1. And you'd be proving that that's true. The only reason I've only a 1 on this side is because I'm adding all these numbers up to 1, which just means I'm just writing down 1. Okay? So I've proved it true for n equals 1. My second step is assume and
Which, you know, if you were doing like 1 plus 2 plus 3, what do you put then into the other side of the formula?
So let's pretend, okay, this isn't part of it, but let's pretend it's for all values of n greater than or equal to 3. Okay, so on this side I'd have 1 plus 2 plus 3 is equal to, on this side I have n, which is equal to 3. Okay, you're filling in.
Is it greater than the number 3 or greater than the 3 in the 3 numbers, the first 3 numbers in the series?
Because of the series, it's the same thing. If n is 3, basically you're adding up to 3. If n is 5, you're adding up to 5. So it means the same thing because of this series. Okay?
Okay, but if it was like 2, 4, 6, would you be adding would you be writing down the first 3 kind of numbers, or?
It would be different then. It wouldn't work the same way because this is just 1 plus 2 plus 3 up to n. For example, example 3 is going to show you what I mean. Basically, you'll have an n in a formula. Okay, and you'll be filling in the 1 into the formula instead of n. See, we're filling in a 1 into the formula here, but basically it's because the series is telling me go up as far as 1. Okay, because your n is your 1 in this scenario. Let me just keep going. When I get to example 3, it'll definitely make a little bit more sense what to do with the n on both sides. Okay, so you are actually just filling in n equals 1 on both sides. okay? But this part is the confusing bit, because this actually isn't necessary when n equals 1. Only this bit is necessary. Okay? If n was greater than or equal to 3, I'd get 3, 4, 5, 6 is equal to, I have 4 here, 4 3s is 12, 12 divided by 2 is 6. So that's how you'd show it if n is any other number other than 1. Okay? But that's dictated by the question. In our scenario, the question doesn't tell us anything, so we're just proving true for n equals 1. Okay? The next one is assume true for n equals k. So all you do in that scenario is instead of n, you replace it with k on both sides. Okay, so that's your step 2. You just say that. Assume it true for n is equal to k. Alright? Step 3 then, you need to prove it true. Or show true. Can I get rid of the board? So I've just taken that last step and put it up there so that I can have a little bit of room, but you just keep going, okay? So show true for n is equal to k plus 1. So what that means is, here, I'm going up as far as k plus 1 on the left, okay? And if n is equal to k plus 1, this changes to k plus 1. Okay, so anywhere I had k, I now had k plus 1. K here, I now have k plus 1 here. Okay? So, back up in your original formula, anywhere you had n, you now have a k plus 1. Okay, that's all you're doing there. Okay? So, on the left, you're going up as far as k plus 1, and on the right, you're replacing with k plus 1. Now, look at that there. You have assumed that to be true, that is equal to this. Okay? So in step 2, you assumed that this thing that I've underlined is actually equal to this thing here. So you're going to replace it. K over 2, k plus 1. So that underlined part becomes this. And I still have a k plus 1 left. Okay? And over here, I have k plus 1 over 2, and I have k plus 2. Now, you're just trying to make the left-hand side and the right-hand side look equal, because you're trying to show that something is true. Okay? So, this k over 2 by k plus 1, that 2 is outside the whole thing, okay, because the top lines are being multiplied. So you could get a common denominator on this side, which would be 2. Now, this already has a denominator of 2, so I'm just left with that. Okay. Here, to get my common denominator, I'm just going to multiply a 2 here by k plus 1. Okay, what did I do to 1 to make it 2? I multiplied it by 2. If I multiply the bottom by 2, have to multiply the top by 2. I'm nearly there now. All I'm doing is writing this out. have a look on the left hand side, k plus 1 is common. So take the k plus 1 out. K plus 1 comes out of this and I'm left with k plus 1 comes out of this and I'm left with plus 2. Now you could multiply all of these out to get two quadratics on the top, but there's no need because I've shown now that the left is equal to the right. Okay, now again with this proof it's really important that you state the following words, okay?
How did you go from the second last line to the last? Like, do you not multiply the k by k and get k squared?
No, so what I said was here, k plus 1 is common. So I factorised out the k plus 1.
Oh.
Okay, so k plus 1 came out. What I'm left with here is k, and what I'm left with here is plus 2. Okay, now you totally could multiply it in if you wanted, but that means I then have to play with the right hand side and multiply that in too. You're really trying to do the least amount of work as you can on one side. Okay, so on this side all I did was just put the 1 plus 1 together and make it a 2, and I left it the whole way down then. On this side I'm just trying to make it look like the right hand side. But if you had multiplied it and multiplied this side as well, it'd be totally fine. Okay, now we need to finish this off, okay? So we need to say, therefore, true for n is equal to k plus 1. So this is number 4. So my steps 1, 2, 3, and then 4 is you learn off the words, okay? So true for n is equal to 1. Therefore, it must be true for n is equal to 1 plus 1. You're rolling it, okay? True for n is equal to 2 must be true for n is equal to 2 plus 1, okay, etc. So you've shown it true to be true for n is equal to 1, therefore it must be true for 1 plus 1, and it must be true for another plus 1, and then you so on. Therefore, true for all values of n. So it's a rolling proof. Generally this part down here will never change, so you can just learn it off and throw it at the bottom. Okay, but just be sure if you we started at n is equal to 1, so you know if you started at any other number you'd start at that number again down here. Okay, let's do another one. Okay, example 2. So prove that for all values of n, a natural number, this series is equal to this. Okay, so the sum of this is equal to this. So 3 plus 3 squared plus 3 cubed up to 3 to the power of n. So our proof prove true for n is equal to 1. If n is going to be equal to 1, it's just 3 to the power of 1. okay, on the left. So 3 to the power 1 is equal to, and on the right, 3 over 2, 3 to the power 1 minus 1. So you get 3 is equal to 3 over 2 times 2, and my 2's cancel. 3 is equal to 3, so that's true. So that's step 1. Number 2, assume a true for n is equal to k. So that just means you write out your series, but instead of n, you're putting k. And same on this side, instead of n, you're putting k. Okay, step 3, show true for n is equal to k plus 1. Okay, so what this means is my series is going all the way up here, and then I have a k plus 1. So 3 plus okay, I'm going 1 after this. And up here, instead of n, I'm putting k plus 1. Now, I know you're probably saying, why is she still including this 3 to the power k when we've replaced n with k plus 1? Okay? The reason I'm still including this is, if this is 3 to the power k plus 1, the previous term is 3 to the power of k. And I need to include this previous term, okay? I could keep going 3 to the power 5, 3 to the power 6, I just don't include them, okay? But it doesn't mean they're not there. The reason I include it and actually write it on the page is because I need to use this bit from my assumption, okay? So I need to see it on the page to be able to replace that with this, okay? So that's what I'm going to do. I've, in my series, instead of n, I've put in my k plus 1, and the same on the right, instead of n, I've put in my k plus 1. Now, I've assumed that I know, instead of this, I know that it's equal to 3 over 2, 3 to the power k minus 1. So let's replace that. So 3 over 2, 3 to the power of k minus 1, plus 3 to the power of k plus 1. Okay, so all I've done is I've replaced the underlined bit with this, and I'm left still with this, and just leave the right hand side. Now, over here, I'm just going to get rid of that now. Over here, we're just going to play around with it a little bit. 3 to the power of k plus 1. I'm adding my powers. Okay? If I'm adding my powers, it means I was multiplying and the bases were the same. So instead of 3 to the power k plus 1, that's really 3 to the power k by 3 to the power 1. Now, over here, let's get a common denominator. So I'm still just working on the left hand side. I'm trying, like I said, I'm trying to do as little as possible to the right hand side. I may need to do some parts, but I'm just going to leave it for a minute. Over here, let's get a common denominator. So our common denominator is going to be 2. So this is all being multiplied, so it's already over 2. So I'm just leaving that. Okay. What I have here is, what did I have to multiply 1 by to get 2? I had to multiply it by 2, by 3 to the power of k, by 3. I'm not multiplying the 2 by the 3. And the reason I'm not multiplying the 2 by the 3 is I don't have any 6's over here. Okay, so I'm basically just manipulating this to see what will it look like. Okay. Now, if I look at this, I can see that the 3 is common on both sides. Okay, so let's factorize out the 3. Okay, 3 comes out, and here I'm left with 3 to the power k minus 1. And here I'm left with plus 2. And that's over 2. Sorry, there's a 3k there, isn't there? So I factorised out the 3. 3 to the power k minus 1 plus, 2 by 3 to the power k. Sorry. So inside this bracket, I have 3 to the power k, and I have 2 times 3 to the power k. So 3 to the power k and 2 times 3 to the power k is 3 times 3 to the power k. So 3 is on the outside, 2 is on the bottom. In my bracket, I have 3 times 3 to the power k minus 1. I am nearly there. Okay. Three by 3 to the power k. I'm multiplying and my bases are the same. So what do you do with your powers? You add them. Okay, so going up here, this is 3 to the power 1 by 3 to the power of k. So that's 3 to the power of 1 plus k, or 3 to the power of k plus 1 minus 1. And if I look over here on the right, that's what I was actually trying to show. Okay, so I have shown it true, therefore true for n is equal to k plus 1. Say your words. So it's true for n equals 1, must be true for n equals 1 plus 1, true for 1 plus 1, which is 2, must be true for n equals 2 plus 1, etc. Therefore, true for all values of n. Okay, so I have one more to do, I think we do it and just get it done. And the more of these that you see and the more you practice, definitely the easier they get. So example 3. Can I get rid of the board? Okay, so example 3. This is 1 by 2, so it's a multiply here, okay? Prove by induction that 1 over 1 by 2 plus 1 over 2 by 3, 1 over 3 by 4, etc. up until 1 over n by n plus 1 is given by this, n over n plus 1. Okay? So we need to follow our induction steps. 1, prove true for n equals 1. So all that means is, instead of this, I'm filling in 1 over 1 plus 1. Which I know you're going to end up with this here. 1 by 2. So that's on the left hand side, I filled in n as 1, and on the right hand side just fill in n is 1. So you get 1 over 2 equals 1 over 2. True for n equals 1. Step 2, assume true for n equals k. So that means instead of n you're filling in k. 1 by 2, 2 by 3, up to k by k plus 1 is going to be k plus 1. So I'm assuming that's true, okay? And we're going to use that assumption now in part 3. Okay, so that is where I'm at here. I just rewrote that up there. That's my assumption. Now I need to show true for n is equal to k plus 1. Okay, so on the left hand side I'm doing this, and I'm going one step further with a k plus 1 everywhere instead of the k. And over here I'm replacing k with k plus 1. So that's what I have already, and then I'm just going to the next step, which is k plus 1 times k plus 1 plus 1. Okay. And on the right hand side I'm replacing k with k plus 1. So I just need to show that this thing is true. We know the reason we leave this here is so that I can replace it with my assumption. So I know this thing here is the same as here, so instead of this I'm putting k over k plus 1. Okay, instead of my underlying part, plus 1 over k plus 1 by k plus 2. Just tidying up a little bit there. And on the right hand side I'm just going to tidy up tiniest bit by saying that. Okay. Now on the left hand side I'm going to get a common denominator, and that's going to be k plus 1 by k plus 2. Now, what did I multiply k plus 1 by to get this? I multiplied it by k plus 2. So k by k plus 2. And what did I multiply this by to get this? It was just 1. So 1 by 1 on top. Now, in this scenario, I can't cross anything out yet. So what you're going to do is you're going to keep going with the left hand side. Okay? On the left hand side, I'm going to multiply out the top line. So I have k by k is k squared plus 2k plus 1. And on the bottom I have k plus 1, k plus 2. I'm holding out with the bottom. I'm not doing anything to it because I'm hoping something's going to cancel and I'm going to be left with the right hand side. Okay. Now, if we factorize k squared plus 2k plus 1, okay, the factors of 1 are 1 and 1. So, just underneath that, I'm going to go over here if that's okay. Under this, I have to factorize this top line, this quadratic, so I end up with k plus 1 and k plus 1. Okay. Factors of 1 are 1 and 1. Factors of a plus are either plus by plus, minus or minus. It must be plus by plus. So that's what I have on the left hand side. And thankfully those k plus 1's cancel. So I'm left with k plus 1 over k plus 2. And that's what they wanted me to show. K plus 1 over k plus 2. Therefore, true for n is equal to k plus 1, and again just rewrite all your words. Okay, okay, so it's true for n is 1, must be true for n is equal to 1 plus 1. If it's true for n is equal to 2, it must be true for n is equal to 2 plus 1, etc. So on, so on. Therefore, it's true for all values of n.